Video we saw the implementation of the program for finding the minimum from the given array. In this video I'm going to write this piece of code in a separate method so that our job of doing selection sort in the next video becomes much simpler. Okay, so what I'm going to do is I'm going to just comment this out here, and I'm going to call the method which is minimum is the name of the method, which takes array as the input, and uh, it returns an element which is actually position, integer element which is a position. Using this position I can actually read what is the minimum from that position, and I will output that position as well. Okay, so let's do that now. Here I'm going to make the NetBeans help here to create the method signature and delete this one, and I'm going to put the same thing basically inside here. Okay, so let's try to do a copy paste here. Let me put it here and Control Shift F for formatting, and it works perfectly fine. Okay, minimum is assigned to F0, position is 0, and the looping, everything remains fine. Only thing is you need to return the position. Okay, now after returning here, okay, so let's delete this one. Now minimum is from A of position, because if I know the position I can just go directly to that location and print the content which will be the minimum. Let's run this program. You can see here the minimum from the array is 71 and the position of the minimum is 5. 0, 1, 2, 3, 4, 5. I think it's finding the maximum because we have the greater than symbol. Let's change it to less than, run it. You can see here the minimum is from position, minimum is 5 from position 1. You can do a multiple run to quickly verify whether your output is right or wrong. Minimum is 5 from position 4. Okay, so the algorithm is working perfectly fine. Now another addition I'm going to do here. Okay, if you remember, I explained you in the previous video that in finding the minimum, you can actually find the minimum from the subarray of the array instead of the whole array. Okay, for example, if I take this as the input array here, what I can do is I can just tell my algorithm, instead of finding the minimum from the whole array, you just find the minimum from this part of the array, which is a subarray. Okay, now here also the algorithm works perfectly fine. Just two things I'm trying to introduce here. I'm going to introduce here starting index of this subarray and the ending index of this subarray. Okay, you don't have to do any comparison for this part of the array because we are not interested in finding minimum from this part of the array. So the output of this finding minimum from this subarray will be 12 from position 1. Okay, so it's not 1 from position 4 because we are interested to find minimum only from this part of the array. Okay, so I'm going to do that. So here also what happens is whatever the element that is present in the starting index will be assumed as the minimum, and the comparison will start from the next position until the ending index. Okay, so this is the usual process that we otherwise do it on the entire array. Okay, everything else remains same. So let's go to NetBeans here, and I'm going to pass two more things to this method. One is 0 and n minus 1. Because why n minus 1? Because if I want to find the minimum of the entire array, I need to specify n minus 1, which is 5. Because n is 6 in this case, 6 minus 1, 5 is the ending index of the whole array. Suppose if you want to find the minimum from the whole array. So let's go and introduce that here. So this is the starting index and this is the ending index. Okay, so let me say here int start index, int end index. Now here what we need to do is we cannot assume minimum always from position 0. It depends on the start index. So minimum is assumed to be from the start index, and position is also initialized to start index. Now just one more change we need to do here in the for loop. What we need to do is we need to start comparing from position start index, and it can go all the way up to less than or equal to, you can say here, end index, because end index in our case is n minus 1. N minus 1 means here n minus 1 is 5. So if I say less than 5, it will stop at this point. It will ignore this ending index position. So I need to say less than or equal to ending index. Okay, so here I say less than or equal to end index, and let's see what happens now. Let's run the program. Because n is not known to the algorithm yet, so I'm going to declare n equal to a dot length. Okay, so now let's run the program. You see here the algorithm works perfectly fine. The minimum is 5 from position 5. Okay, let's run one more time. Minimum is 0 from position 4. 0, 1, 2, 3, 4. Okay, so the algorithm with just minimal change, it is perfectly working fine. The minimum is 21 from position 3. Okay, so now what is the advantage is, for example, now I can play with the starting and ending index. If I want to find out minimum from only first half of the array, so I'll say 0 up to 4, because size of the array in our case is 10. 0, 1, 2, 3, 4 comprises of 5 elements, so 0 to 4. So I'm just trying to find the minimum from the first half of the array. Okay, rest everything remains same. I don't have to change anything here. Let me run the program now and show you the minimum in the array is 30. Okay, and it is in the position 4, and actual minimum is also 30. Let's verify. Okay, you can see here the minimum is again in the first half. Okay, let's run it several times. Again the same thing, again the same thing. Okay, so now here the minimum is 48, again in the first half. Let's do one thing. Let's change the range from, instead of 0 to 4, let's change it to 5 to 9, because most of the random numbers that we generate, always the minimum lies in the first half. Let's change it and see. Now the minimum should be computed from the other half of the array, starting from position 5 to 9. Okay, so you can see here 5 to 9 means 0, 1, 2, 3, 4. We are trying to find the minimum from here. Again, unfortunately, the minimum is in the actual range. Let's run it one more time. You can see here minimum is now 5, and the position is, okay, again here typical case. One more time. Okay, luckily this time you can see here, although the minimum is in the first half, because we are interested to find the minimum from position 5, that means from 24 to this range, minimum is 24 from position 5. Okay, so like this you can change the range also. You can change from 1 to 3, you can say here. Okay, just change those two starting and ending indices. Run it. 1 to 3, 1 2 3. The minimum is 57 from position 2, although we have other minimum 9. Okay, so this is a very useful algorithm going into selection sort in the next video. So students, with this we are almost, I can say, 70% of our algorithm for selection sort is ready. In the next video I will show you how the selection sort works, and I'll make use of the same exact code in the implementation of selection sort algorithm. Please note that the time complexity of finding the minimum is order of n, because we have one for loop which is directly depending on the input size. Okay, see you in the next video.